once you start the samples, I mean, basically you either get good data or you ruin the samples. So it's do or die at that point. So you want to make sure everything's running properly. This is a very clean area, by the way. So it has a filter at the back and air is being pumped through this filter. And so as you can see from this, the air is flowing out and there are absolutely no particles in there whatsoever. It has some designation of less than so many particles per cubic meter. And that keeps everything clean. We have to do that because we're measuring iron, aluminium and manganese, and iron in particular is extremely contamination prone. So the way the methods work is, right now there are 8 tubes here which are blue and 8 tubes here which are green. These tubes are for samples. Now they're all in one bottle at the moment because I'm just starting the system up, but normally when I'm running samples, each one of these would be in an individual sample bottle, which is like this, one of these. And these tubes deliver the samples to the aluminium and iron system, which are coupled together. And these tubes deliver the samples to the manganese system. And the way they do it is these pumps are pumping continuously, and the sample lines come up here into a valve. This one is for the aluminium and iron, so we call it Alphi, because those are the chemical element names, and this one's manganese. And depending on which way this valve is rotated, it will suck up just one of these tubes. And we can program this. It's all controlled by these nice Macintosh computers. We don't do Windows. And we can select which one of these lines will the sample will be sucked up, and then the sample comes through here and comes out. It mixes. The samples are acid, and we mix them with a buffer, which is something that just raises its pH a bit. Comes into this valve, and depending on how this valve is set, if we are going to measure a sample, we'll pass the sample across this column, which has a resin in it, a very special resin, which will absorb all of the iron out of the sample. So what we'll do is we'll pass the sample across that for 3 minutes exactly. Then the valve will switch, and then instead of the sample going across here, we'll counterflow, in other words flow in the other direction, some fairly strong acid. And when that acid comes along here, it releases the iron. So what we've done is we've managed to pre-concentrate the iron on this resin for 3 minutes, and that's roughly about 7.5 mLs of seawater goes through there. And so that comes off in this pulse of acid, so it's much more concentrated. And it's hard to know exactly how much more concentrated it is, but probably on the order of, I would like to say, maybe 50 times more concentrated than it is in the regular seawater. So the iron, if you imagine, it's flowing down here in this very acid solution. It then starts to mix with a variety of chemicals. This one here is actually the chemical that we're going to measure in the end, which has already been mixed with another chemical down here. They flow along together, and then finally another chemical is added right at the end. And then all three, so these are all the chemicals are now mixed together, and it's the right reaction conditions. They flow into a coil that's buried inside there, and it's kind of hard for you to see that, but it looks like one of these. And essentially what that coil does is it allows the chemicals to mix together, so it's like one of these, and it flows along here. And this is just basically a long piece of this tube that's knitted together. I don't know if you ever did this in grade school. You do that kind of crocheting. That's exactly how we make these. So when we run out, I'll be coming and asking you guys to make us some more, because I've forgotten. Anyway, so it flows through there, and it goes through this heater. Actually, for the iron system, it doesn't need to be heated, but we're trying to keep the temperature constant. So if you heat it a little bit, that means you damp out the temperature fluctuations in the vat. Anyway, it comes out of the other end and then goes into this machine, which is a spectrophotometer, which can measure color very accurately. And what happens is that the solutions, you can't really see the color with your naked eye, but it looks pretty clear. But when the iron reacts with this particular compound, it makes a pink color. And this can measure the pink color, and this number will increase as the pink color goes up, and then it will decrease. So it's really, actually, it's pretty simple stuff. And all of these chemical methods are actually pretty old methods that we've just adapted to this flow system. And the nice thing about the flow system is once you get it running, which takes quite some time, you're not going to get contamination because you don't touch the samples.